Isaac Newton, the guy under the apple tree. He's the founding father of calculus, optics, and physics. If you've ever seen a NASA's large telescope, you have him to thank for that. And the speedometer on your car, him too. What we know him for is his 3 laws of motion. Does anyone know his laws?
This is stupid.
Excuse me?
Come on, Teach. When are we ever going to use this in life?
I have to agree, this isn't making a lot of sense, and it's honestly not very interesting.
What? Physics is awesome!
Let's face it. Forces, motion, gravity. Not only is it all painfully boring, but it's useless. Yeah, I'm not staying for this. Sayonara, Teach.
The bell doesn't dismiss you. I do.
Wait, where's that music coming from?
And nobody's getting dismissed until we've covered and you've realized how important Newton's contributions really are, right? And I'll give it to you step by step with 3 simple laws.
An object in motion will stay up in motion. We go with the flow like the waves in the ocean. If friction is 0, you know that's the notion. When on a smooth surface, the object is coasting. Not bragging or boasting, but here's number 2. F equals ma, and that's always true. But a is a vector, so keep that remembered. Direction of force can be negative too. Law number 3, now kid, this what you gotta get. Forces in contact are equal and opposite. Throw up a 3 like I'm playing for Popovich. Opposite force makes it bounce back and pop again. Take for example this ball in equilibrium. Net force is 0 like hairs on Prince William. You best get this straight though, because it's got weight. Then the normal's the same if it's 1 or a million.
Appreciate it, Teach, but just one thing's not clicking. Something you're saying just isn't convincing.
You want me to believe that there's force on an object that's not even moving? Nah, you must be tripping.
Oh boy, we have a lot to observe. Not only is this true, but it's the same for reverse.
An object can move if its net force is 0?
You guessed it, amigo, just wait for this verse. Equilibrium will mean velocity is constant, cause all the force applied will balance out as correspondence. So as long as it's in balance, no matter what's the challenge, then acceleration's 0. How awesome of a concept.
Cool, but what if F is applied at an angle though? All this talk of forces got my mind in a tangle, bro.
Really, it's as simple as to find the component force. Split it into X and into Y, a triangle. So, let's solve this problem for direction and magnitude. Breaking down this force up into parts, what we have to do. Cancel out the X and you'll be left with the altitude of the net force in the Y. That's the answer, dude. In the direction, it's nothing to be stressing. We know the answer's up and all it takes is some inspection. Cause gravity and normal force just cancel out each section. And the only force that's left points up, that's our selection.
Okay, you got me. I get forces do stuff, but what's that to do with that guy Isaac Newton?
Like, what's with that apple? It's something I'm losing. When it fell from that tree, what's the point? What's it doing?
Remember gravity and think about its relevance. So listen clearly to my speech, no impediments. It makes a way if it's an ant or if it's an elephant. Just hear me out, I'll make it quick, make it eloquent. You know it's evident, what comes up must come down. Gravity's a constant, when on earth it goes all around. Gun away the same in Centerville or a Tuscan town. Step up on a scale that's on the moon and you lost some pounds. But not actually, look at it factually. Because its mass is smaller than the earth, so it's that gravity. FG on the planet is GM over R squared. No, the moon is far less dense and we are there.
Wait. So you're telling me if you drop a heavy object and a light object at the same time, they'll land at the same time?
Exactly. The gravity on every planet is its centripetal force. Take a look at this.
As we know, force equals mass times acceleration. Thus, the acceleration of gravity on the planet depends only on the mass of the planet, not the mass of the object. If we plug in our known values of Earth into the equation, we're left with 9.8 meters per second squared as the constant deceleration on Earth's surface, no matter the object.
I can grab any 2 objects of any mass, and as long as I place them at the same height, they'll land at the same time.
What if you threw one farther away? Wouldn't they still land at the same time?
Well, obviously not, because the object you throw farther has a larger distance to cover, so it's going to take longer to get there.
You must be forgetting that gravity only applies in the Y direction. So even if I drop this apple and Maria throws her pen forward, as long as they're the same height and time, they'll land at the exact same time because
the x component of velocity is independent from gravity.
So, Ahmed, did I convince you? You love physics yet?
You know what? You could leave me here in this room all night, show me all the forces, gravity, whatever, all the laws you want to show me. Throw all the apples in the world. But you're not going to convince me. This is useless. When am I ever going to use this in life?
The car you drove to school today, you think that's also useless? Without what we're discussing now, you wouldn't get it moving. What about the plane that shipped the pencil that you're using? All of its dynamics, kid, before you think it's fruitless.
Some of this doesn't even make sense though. Like, how can an object just keep staying in motion? How is it like not gonna stop ever or anything like that?
Guys, why don't we take this outside?
Let's roll this ball on a surface that's smooth. Those itty bitty bumps won't mess up its groove, cause its coefficient of friction times normal won't make much of a difference to finish its move. Now roll the ball on a surface like grass. The bumps on the surface are more in contrast. Now its coefficient of friction times normal is enough resistance to stop on its path.
Hold on just a minute. I once heard from a guy that energy cannot be created or die. So how you gonna tell me that a ball with some energy just somehow eventually stops? That's just a lie.
Well, if it's running, then it won't just deplete. But you gotta understand the energy will just leave. And if it starts as all kinetic, the friction will mean
all the energy it loses is converted to heat.
And now it's thermal, all that energy raises up to heat. Follow me on the count of 3, rub your hands like me. As you see, all the energy raises the degrees, like you teach when he's on the beat, turning up the heat. Don't get it twisted, cause here's the part that really gets interesting. What's more thermal energy, an iceberg or some coffee?
I know you're trying to trick me, but your question just can't stop me. An iceberg is like colder, so it's obviously some coffee.
Wrong. Think about the molecules and passage. You mix it up for temperature, so listen, no distractions, cause thermal is the total energy of all the molecules in motion in an object, and temperature's the average. Thermal energy is found by this equation, and mass is right there and in consideration. And since an iceberg is more massive than a coffee cup, then even if it's colder, Q is more. How amazing.
Do you get it now? Is physics finally fun?
Means I can get out of class. Yes, I love physics.
Well, that sure was a crazy physics class, but it was pretty fun though.
I guess.
Did you actually like it, or were you just saying that to get out of there?
I just wanted to leave. I don't care about physics and forces and all that, but
Well, maybe you'll like physics someday.
whatever.
Well, I gotta get out of here, so I'll see you later.
See ya.
Yes, I am hopeful for today. Take this music and use it. Let it take you away. And be hopeful, hopeful. And he'll make a way. I know it ain't easy, but that's okay, cause we hopeful.
I wish that you could show some love instead of hating so much when you see some other people coming up. I wish I could teach the world to sing, write some music and have them tripping off the